Welcome back. Here I've drawn the circuit again. I've separated out the op amp to show that it's an ideal case and we've got no current flowing from the circuit into the op amp. Alright, so first I'll introduce my current loops. I'll call this one IA, IB, and IC. So I've introduced three unknowns. So I'll need to generate three more equations, and I'm looking for Vx. So let's see what we've got. So let's do the first loop. So we'll just start at this point right here and assume everything's going to sum to 0. So the current's traveling counterclockwise, so it goes through Vi, so it's going to be Ia times the drop in voltage. This is a negative voltage, so V1 plus, again, a drop in voltage. The drop is negative Vx plus, when it goes through here, the drop in voltage is the current going through the 2K resistor, which we've got IA, but then we've got this current coming back the other way, so it's negative B times 2K. And by the way, I'll keep the 2K designation. And then here we've got the current IA less the current IC times the resistor 4K. And we're back to where we started. So that's one equation. Let's go into the second equation here. So let's start right here. So we're going to start, so the drop through this resistor is going to be the current IB times 2K. Then it goes through here. Now what happens here? Is there a voltage drop? Well, we don't know, so we're going to have to designate some more unknowns. So let's call this VB. Let's call this VC. So the drop here, we're going in that direction. So it's IB minus IC plus the drop, which is VB minus VC. And then through here, in this direction, we've got IB minus IA, because it's going in the other direction, times the voltage drop, which would be VC minus, what's that right there? So we're going to need another unknown there. Let's call this VD. So it's VC minus VD. And that's our second loop equation. Let's do for the third loop equation. Let's start right here at V1. So we go through this resistor, this 2K resistor, so we've got IC times the resistor there, which is just 2K, plus the current IC minus the current that opposes it, which is IA, times the voltage drop. We're going to need another variable here. Let's call that VA. So VA minus VC, and then it goes through here again. So again, the current is going to be IC minus the current that opposes it, IB in this case, times the voltage drop, which is VC minus VB. and we've got more. We've got to go through this 4K resistor, so plus IC times VB minus 0 because we're at ground here, and then plus the current goes through here again, so it's going to be IC times the drop in voltage, which is 0 minus V1, and that's our third loop. So we've introduced quite a number of unknowns here, so let's see how much we have. We've got 1, 2, 3, 4 unknowns, 5 unknowns, which is V1, plus the 3 currents, we're up to 8. Some of these are going to simplify, I believe, because we've got, well, Vx is probably going to replace one of the unknowns, so that doesn't help. But these currents might be able to be replaced because these currents are going, well, actually they're just going to give us extra equations because these currents add up to some of the source currents. So we got 3 equations so far. It looks like we need 8 equations. As you can see, this is getting out of hand at 8 equations. No way you're going to be able to do that during a test. So, too many equations. We could solve it this way. It's just going to take a long time. So this is our first hint. We're going down the wrong path, or at least the least efficient path. And a better job might be to do superposition. So I did this so we can see how the equations begin to build up. As long as we've done everything correctly, we will eventually arrive at a correct answer. It just may take a long, long time. So let's leave it there and stop the video and then come back and try again, but this time use superposition.